Okay, I begin. Thank you for coming. This talk has an history. Last year, the last day of work for me, it was September 30 last year, French people in Paris asked me to give a provocative talk. And it was also the last day of working of the president of the association, this association related to secret services in France. And so the question was, what is the future of cryptology? It's a big question. And there was a parallel with Titanic. So we'll see it is the story of Titanic and some three-letter algorithm like RSA. Okay, so we are here in Berliner Congress Center, Berlin, Germany, Earth, Milky Way, and at the moment we are in the Universe 1 version beta. Be careful. Maybe at some stage of the talk we'll be in the Universe 0, 1 bis, third, and so on. So think about that. Okay, so we begin, except that last remark, we are in the hacking session. Alas, it's not true, we will not hack anything today, maybe later. So we are really in science and culture. So culture about Titanic, RSA, factorization, history, and the future. So we begin.
I would be glad to begin, but yeah, my mic is working, that's perfect. So we'll just begin by something common. Just say that everything you will see on this presentation, everything we'll say, it's all copyrighted, we have the right for everything, we are not some bad hacker, all the name, brand, image are copyrighted, and we want to thank people who allowed us to use the material. So you have some name downstairs, and thanks to them.
And thanks to Deep Ocean Expedition, indeed, we have the permission from there, and above all, Ron Rivers.
Ron Rivers, of course.
Okay.
Then I will try to present a bit who are speaking to you today. So you will see three faces. In fact, this presentation is supposed to be done by David Samid, but he's not here today, like usually. So I won't place him. So I will do my max. I get the presentation 4 days ago, but I think I will be able to speak with you about what he said. So we have a lot of nice things about him. We are all French speakers, so let's apologize to our English and our bad accents. I have a nice pictures with some hair. I don't have hair anymore.
Okay, okay. So not put on.
Maybe I can say that Jean-Jacques can maybe introduce himself because he's better than me for this.
Okay, so I did a lot of things. I am normally retired, but I was teaching this week. And I was the former head of the UCL crypto group and also at Philips for the same crypto research labs. And, well, okay, we are ready to begin.
Part 1, Introductions. Explanation of the title. So that's something I will speak with you about. For a lot of people, that would be strange. It will bring you back to your childhood when you were at school and speaking about history. But if you really listen me carefully, and if you keep in mind what we are speaking about, when I will speak about Titanic, you will get the message. In case you don't get it, our professor will explain you better. It's going a bit fast now.
One remark, don't worry too much about the world text. There are too many slides, too much text, so we will skip.
All right. We're just speaking about Titanic. Why Titanic? First, Titanic, everybody know about Titanic. It's one of the 10 most known words in the world. with Coca-Cola, sex, porn, and other words that you know, all of you. We speak about 3 letters algorithm. 3 letters is not only RSA. For a lot of people, when we're speaking about crypto, people will say RSA, but it can be AES, DES, Bloom, Shum, SHA, and a lot of. They are all in same family, and we don't make, today we'll not make some precision on some one algorithm. We're speaking about generality. Then we're still on the same slide, that's good. So, and then we'll speak about the problem. Titanic had a problem. You all know that. We kind of believe that algorithms, as we know and as we use them today, can have a problem. And that's maybe a bit the goal of this presentation. It's to open your eyes and for everybody to be aware that, as people used to say, Titanic couldn't think, it did. We can have the same problem with the algorithm we use today. Perfect. That's Mr. David Samit, the guy which is not here, who made the slide. So that was some kind of humor from him, I believe.
Yes.
We can go to the next one.
Yes.
Now we're speaking about Ron Rivers. So for people who don't know who is Ron Rivers, you can use Wikipedia. But he's one of the guys who invents RSA, one of the 3 guys. And he told us a few things about algorithmic, which is, I believe, interesting. He explained that factoring RSA could be easy. Could be. We don't know. Until now, nobody did it, but he said it could be. He said something else. He said that to go to another system, it can be easy too. That's something personally I'm not so agree. It's like people saying after the Titanic, because I'm still speaking about the Titanic, that Titanic could think it's true. Everybody to survive, it was another story. It would be better if we will be prepared before. Agenda of the talk. We just did the introductions. It's done. We'll have a second part about Titanic. I will have the pleasure to speak for this part. Then we'll have another party about crypto with conjuncture difficulties. Yes. That will be our point of view about nowadays crypto. And then we'll have a last part, will be maybe, for people who still didn't get it, the mix of both. Why we use Titanic and why we can see that it's a lot of common points between these two. And of course, you will have a nice conclusion at the end. Titanic. So that's the part I will present you. So it will be historical facts. After, I leave your imagination to make it going with the topic. As we can see that the Titanic, I will not say nowadays, because this picture was taken 20 years ago by some Russian submarines, the first to discover the Titanic, another story. As we can see, the Titanic is not eternal. Right now, we have some bacteria eating the metal, and depending on experts, in 100 years, it will be no more Titanic. Size matter. Titanic was a big boat. I say big, it was a huge boat. We can fit inside Titanic a lot of things. They are coming. Human. That's one small human. You can see it here too. But we can put much more than human. 1, 2, 3. We can put some car, some bus, or some Airbus. In fact, we can put 3 Airbus. It was the biggest boat ever at this time. Nowadays, we had Queen Mary II, which was bigger, but it's still the second biggest boat ever. For information, you don't have the image anymore, but for people who remind them, it has 4 chimneys. The last one was just for decorations. About fact of Titanic. The fact, as you can see, it's a lot of number, and it's a lot of huge number. One more time, it was the biggest ship in the world, and the most secure ship in the world. You have to know that all the best engineers worked a lot for making this ship, which was a special order, as the biggest and as the safest in the world. As in cryptology, we have RSA and others that I spoke before, sister. Titanic had some sister too. He had 2 sisters, the Olympic. So here you can see for the Second World War, it has this war painting. Like it was difficult to see how fast it was. And we have the Britannic. Both of them sank. Britannic on a mine, and Olympic by some attack of a submarine. So it's not only Titanic, but all Titanic sisters sank too. Then on this story, we have another thing, an iceberg. What we have to know is the iceberg was here before the Titanic. But as patience is a virtue, iceberg was nicely waiting for the Titanic. So for 2 years, iceberg was making a nice turn and slowly going down, waiting for the Titanic to come. You know the rest. Security precautions. Titanic must be the safest boat in the world. So engineers work a lot to make a lot of precautions. First, captain, we knew that it was some iceberg, took another route. He go more south. Unfortunately for him, the iceberg too. Second, they had the best radio at this time. It means they had radio operator which can talk 600 kilometers abroad, which allowed them to, in fact, reach the mainland. Then, they had the best captain at this time. This captain would just make the first trip with Titanic. It was his last trip. It was his last trip, that's true, but it's supposed to be his last trip too, because he's supposed to be retired. It was an old captain which had a lot of experience. Then, Titanic, like everything, had problem. Titanic received a lot of warning for other ships around that iceberg are around. But as Titanic was a huge boat, costing a lot of money, companies were supposed to make money too. That's how we're living. And the operator was not supposed to make all kind of communication we normally making on ship, but better to make communication for family and for rich clients. Hi, how it is on Titanic? Oh, it's good, we're coming soon. Blah, 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 blah. So it was a priority. It was to make money with the telegraph. That was one other problem. Other problem is, as you saw, Titanic has 2 sisters. So the crew supposed to be on Titanic at start wasn't the crew on Titanic when the Titanic sank, because the crew was splitting between other boats. And then, a bad condition, no binoculars, that's something funny, but no way to see that a big iceberg is coming, because binocular was in some case, and the only guy who had the key of the case was in another boat. Iceberg. Iceberg was a big iceberg too, for sure, to get the big Titanic, 30 meters high. what we can know after for the collision is when Titanic hit the iceberg, people don't feel it. It was not a big crash, it was not, as you can see on the movie, like everybody, like, no, it was a small shock. So, officers, of course, go to check, but for them, it was done, they hit, and it was no damage. We can see that 20 minutes later, they was under the sea. Then, yes, we can speak about number 2. What's interesting too is the ship sank in 2 hours. On 2,223 people, 1,517 died. Lifeboats had only 1,178, so it means that some people die even with lifeboats. And by regulations, the law, 34 people of passengers supposed to have a lifeboat. It was not the case. Why? Because it was not very nice, very attractive to see a lot of lifeboats. It takes a lot of place, and rather than to put passengers there and to get more money.
Can I ask you a question? And especially the audience a question. Who came here for an attack? Wait for the factory.
One, two, wait, no wait, question.
Wait.
Okay. You will wait a bit, and I will answer you. Sorry. These organizations, as we spoke before, it was not enough life jackets. People fought for life jackets. Then, when the Titanic hit the iceberg, it was a bit panic when people begin to see that the ship is sinking. So, captain make an order, children and women first. People understand only children, only women. So a lot of small ships for saving people were kind of empty because all children and all women left, but crew said it's only children and women. So problem of communications, problem of signal, because a new signal SOS that you all know was applied since 2 years. As I told you, the captain and the crew were kind of old, so they used the old CQD. So a lot of other boats didn't answer and didn't get it. They get problem with radio, because they ask a lot of boats around to shut down their radio because it's made a jam for their personal transmissions, which was important to get money again. And
it's okay.
That was these organizations. Irons, what's happened Irons? Irons, when Titanic sank, it was couple boats. It was the California, which was the nearest one. Unfortunately, California had to switch off its radio because Titanic asked, it's make jam, please switch off your radio, we have to make some passenger transmissions. So California wasn't aware of the problem of Titanic. It's pity because it can save everybody. It was only 20 minutes away. We had Carpathia 2 hours away. We save most of people. Then we have a lot of other boats. What's important and funny too, it's Olympic, the sister of Titanic, didn't move. When they receive the message, they think that it's done, that they couldn't do anything. Some small story about Titanic, some glitches. Captain Smith, not the same than in Matrix, was the millionaire captain. Thanks for laughing. As I said, he was an old captain that everybody well known in the world. A lot of passengers was waiting for him to be captain, and they used to call him the millionaire captain because all rich people really wanted to be on boats driving only by him. Another glitch is Titanic was delayed for 6 months because of preparation of a sister boat. It means if Titanic will leave 6 months ago, iceberg will not have time to reach him, and we don't have this catastrophe as we know. Then we have other things, as the key, as I already said, and as the staff, which was split in two. We found Titanic after. You can even visit Titanic if you have a lot of money, with some submarine. A lot of people think that Titanic sank intact. It's not true. Because of the pressure, Titanic split in two. The first we find Titanic was the US Navy. In fact, US Navy lose 2 submarines, so they sent somebody to find these 2 submarines, especially it was nuclear propulsion submarine. But they said to everybody, we send a boat on submarine to look for Titanic. In fact, it was for looking for the submarine. They find submarine and they find the Titanic. If you want to know more about this submarine, you can read some very nice book about the K-129, which is a Russian submarine, and you have all the story about this propulsion and everything. It's fascinating. Claim reactions. Titanic was built to not sink if 4 of its tie compartments was full. Unfortunately, 5 of them were full. And then is a domino effect. Because it begins to go down, the water begins to go to other one, and step by step, Titanic sink. Think you own Titanic. You can do it at home. So you can rename your phone Titanic, synchronize it, and sink Titanic. Or you can buy on eBay some kit. You put it on your tubes, and it's kind of working. I tried on my shower, it was not perfect, but I saw video, it is working. Interesting character. We have Violet. Violet was very interesting because I think she's one survivor, but she's the most unlucky one. She gets 3 trips with the same company, and 3 times the boat sink. The third one, a lot of people didn't want to travel with her. They were right. We have Williams. Williams is interesting too because before going to the boat, he said, the boat will sink. Yes, it did, and he died. And we have Astor IV, which was the richest American guy at this time. If we compare his money with Bill Gates now, he had twice more money. He died on the Titanic. And people said, but maybe it's a rumor, that his last joke was, I asked for ice on my whiskey, but not so much. Believe it or not, that's a true thing that we found, and we find it funny, so we share it with you. 14 years, I'm French, before Titanic, some people write a book about some ship named Titan, who was same, unsinkable, kind of as big, and on his book, it sank and people died. And that's true that 14 years ago, Titanic did kind of the same. It has nothing to do together, but we find it funny, so we share it with you. And then last thing about Titanic, and then you will know everything about Titanic. It's, in few days, it will be the 100th anniversary of Titanic. And if you are rich enough, you can visit it with deep ocean expeditions, which can rent this. It can be 2 of you, and you can go to visit the Titanic. So if you listen me enough, and if you try to put what I said and change Titanic by cryptology, maybe you can get an idea of what we're going to speak now. If you don't, we will repeat it for you.
Thank you. So we continue with the part 3 about cryptography with conjugate complexity. So you see that it's related to the conference. See. Okay, continue. Well, next year is the year of Titanic. Yes, maybe, but it's also the year of Turing. And, well, Turing did a lot of things, including the cryptanalysis of the Enigma. Okay? And, well, here maybe it's time to recall the Kerckhoff principle. Security must be only based on the secret of the key. And it's also the so-called the Shannon's maxim, the enemy knows the system. But what about today? We need secure hardware, we need secure primitive based on conjectures, and, for instance, strongly difficult factorization. So maybe we need to set a new principle. You see that not only the key we need to secure, but many things. So cryptology is changing. Well, you know a little bit RSA. Here is the algorithm. Here are the inventor, including Ron Rivest. And so you know that factorization of n, or the use of composite number allows to encrypt, decrypt, sign, and so on. Okay, so we have for factorization and discrete lock in cryptography, we have a lot of names. Then some names were not known a few years ago, Ellis, Cox, Williamson, for instance. And we know Merkel with a paper rejected, and the main paper is Diffie-Hellman, New Direction of Cryptography. And in fact, maybe you don't know that Rivest Shamir, not Edelman at MIT, was trying to prove that Diffie and Edelman were wrong, and, well, sometimes it happens, they invented RSA. So here, the visible tip of the RSA is Diffie-Hellman and the RSA team, but the iceberg is maybe much bigger. So, as you know, you have a lot of RSA modulus in the room, everywhere, for many years, not only PGP, and is protecting a lot of money every day. So if you have factorization in your hands, maybe you will, or you want to be a billionaire, or maybe you will have a lot of trouble, a lot of new finds, and then so on. Some visits, indeed. But let me remember again, factorization was an hobby, in fact. Well, you have Jevons in 1874, so he published a challenge and asked, can the reader factorize that number? And he said, I think that is unlikely that anyone except myself will never know. Well, you see here the information, and the result is Lemmer, the father, was able to factorize it less than 30 years after. So a formidable challenge was coming trivial. And there was another fact. Cole was able to factorize, for that time, a really big number during Sundays. Okay. Well, now we have a more complete timeline for RSA. Maybe you don't know that in 1854, Babbage proposed to use large integer for encryption, and it was 100 digits. Jevons invents the one-way function called induction and inverse operator. He said, what if, and it is normally, encryption is easy, while the cryptanalysis is not. Multiplication is easy, while factorization is not. You see here the invention of one-way function, long time ago. Well, as you know, physical public key was invented by Bell Labs around 1944. Kennedy, the president, US president, asked to invent signature, one signer, or able to verify. After that, more or less in parallel, but before, Ellis Williamson Cox invent public key, RSA, Diffie-Hellman. Rabin invents probabilistic parent testing and signature. And Hellman, thanks to DES, invent asymmetric cryptography. At the trapdoor, Diffie adds the protection of privacy, and Merkel applies it to key distribution. And again, Knut, one now from Stanford, is coming back to the last century and proposed to use easy multiplication versus factorization of large integer for the design of public key. Gill then proposed to use discrete lock. So you see the story of RSA is not totally linear. It's a long time. And Rivers and Shamir try to prove there is not a system. But as I said, invent RSA, and Adleman adds proof from number theory. Okay, so in fact, if you are thinking about factorization, at the moment, there are very limited progress on the theory. There are a lot of optimization. And the question is, are we in the right direction? Is it possible or not to drastically accelerate what we know by improve, for instance, the polynomial selection and so on? And more important, maybe, are the criteria of generation for the primes, the RSA primes, still valid today? I'm not sure. Well, so we are coming for a very important point, the so-called Rivest law. It is foolish to predict when an integer of any particular size may be factorized. So it's, Ron Rivest is saying, today we are maybe very secure, and tomorrow, maybe not. We don't know. And so the question is, well, are we ready? Like the Titanic was ready or not? And we have prediction. For instance, at the International Workshop on Post-Quantum Crypto in Leuven 5 years ago, Jacques Stan predicted, in fact, the end of the RSA. Not me, Jacques Stan. And the date is here. More recently, based on linear extrapolation on the progress of GNFS, Paul Leland said that RSA 124 will be factorized on that date with that precision. Yes, why? Well, okay. So you see that people are saying we are secure for the next 20 or 25 years. But Rivers said it's foolish to predict. But people are doing that. And more, everybody is acting like the predictions are correct. We are thinking about that. So you understand now the direction of the talk. Are we ready to implement the reversed law? I mean, taken it into account. Not saying, yes, it's a law, no. And we are not ready, in fact. No, reversed, but 20 years ago, did also some predictions. So you see that there were, the law is in bit. The low level of number, secure number for the years, and here average high. And what is done? You see that in 2000, in fact, you can kill the first column for the prediction of reversed. 5 years after, you can kill nearly the second column. Oh, the game is coming to be very dangerous. And here we are. It's not so good. We are not killing the last one, but we don't know. Now, Bruchner did also prediction. It was very simple here. So you see, you add here 10 years, and here you multiply the size by 2. And in fact, this table is in use today by some people, government, and so on. Why? I don't know. Here, if you go to the keylines.com, it's not prediction there, it's what you need to use if you use the Lenstra laws or the result from ECUP2 or from the NIST of the FNESA, when I say of some internet RFC and so on, and you see that normally for the next year, you need to use for RSA something like 2,000 bits. The smallest number is 1,120. So my question is to the audience, who is using a larger key for PGP? So the other ones you need to change. Okay, but okay, continue. Now, there is a curious collision between the Titanic and number theory. There was a publication here by Samuel Yates, defining Titanic prime to be the number with at least 100 digits. And here you see there is something not totally correct. Samuel means here very large prime, not prime like the Titanic ship. Dangerous to do that. So you see that the product of two Titanic primes, it's at least 6,000 and more bits. And number for cryptography are today in use in some specific application. There are some PGP keys like this. Telecom industry is using that, and so version of SSL. And so the product of two Titanic RSA primes are Titanic RSA modulus. Very dangerous expression. Okay, so what if? And if means integer factorization, and if something is going to be wrong. So here we continue to use some citation from the Titanic. So the captain, so you remember the Captain Smith about one of the 3 ships? I cannot imagine any condition which would cause a ship to founder. I cannot conceive of any vital disaster happening to this vessel, but modern ship building has gone beyond that. It was before the story you know. Well, another quote from a Titanic passenger: to say a ship was unsinkable was flying in the face of God. But some employee at the launch of Titanic, not even God itself could sink this ship. Very dangerous to say that. So you are exciting the gods. Okay, so we have the same citation about factoring. Richard Guys wrote, "I shall be surprised if anyone regularly factors number of that size during the present century." Oh, very dangerous to say that. But there is, the crazy citation is this one from the RSA team in Scientific American. The RSA 129, so it's 426 bits, will require 4 quadrillions years to factorize. It's a citation, it's not a joke. I asked to Ron Rivers why they put that crazy number. Well, first answer, because we are not thinking to work in parallel. But okay, it's not the point. And we did an error in the computation. This number was factorized 70 years after. Now, there is a problem, because you know that maybe cryptography, RSA, is good, but not that much, not too much. We have to be careful. But no, we need maybe to come back to reality. And here we have a citation for Tolstoy. The meaning is, if you say something during to everybody during your life, it's not easy to say, yes, I was wrong. It's a long citation from Tolstoy for saying that, and it is the point, I think.
You can find it back on Wikipedia.
Okay, there is another problem, is the black swan effect. Here a lot in Australia. And in fact, white swan were very well known in Europe, no black. So people say, we don't see black swan, so the people did not believe that it's possible until it was in Australia, somebody found it. So it's maybe the same story. Well, it's the same story for IBM chairman predicting that 5 computers in the world will be enough. And so we are here in the black swan reason. Events are to predict. Think about the reverse law, big impact on the society, think if you are say broken. And maybe after that we'll say, if it is happening, it was normal. Some people say that, well, okay. And so maybe the talk is also, maybe we have to be ready in case of. There is another view of that, is the so-called elephant hiding in the phone booth. Many people are working but they don't know maybe if they found it or no. Sometimes people miss something very important. An example one know is the can opener was invented 50 years after the first can. And Tasman discovered many Iceland, but he missed Australia. So the question is the story the same for all the things we know about for cryptography? And there will be maybe so few answer. Daniel, maybe we are not happy, saying it's possible to stop, depression, acceptance. So you see if it is happening here, you see all the possible reaction. This cannot be true. Well, why? Who is to blame? Maybe there is a way to stop it. Why bother? It will be okay. It is not the end of the world, and we need to find new solution. Let's learn from errors. Okay, so coming back to Titanic and factorization, there were few events before Titanic with the same story. And people were not thinking a lot about that. And so they were not anticipation. They say, oh, it's one event, don't worry for the next one. And it's not exactly what we are saying here. We risk managers should have plans and schemes and should be ready. And for instance, speaking again about the Titanic, maybe people were thinking at the time that the probability of a collision was really low. Here is a map of ship collision with iceberg. So you see it's a lot. No, so there will be a catastrophic failure if algebra put some answer we don't care about at the moment. So maybe it's possible also that some group, not so nice, the name is maybe algebra, to use mathematics as a weapon or a cyber weapon. So think about that. So be careful under your research with care. No, is it only the talk? Think about that. There are a book about that. They track this from Harry Jules, working for RSA company. And the story is some cult knows how to factorize integer and keeps the secret. Well, okay, it's a book. Think about the sneakers. Well, okay, a team of 6 people gets their hand on a factorization device. And what to do with that? Well, and it is the beginning of many problems. And there are also, it was on April 1st, a paper factoring is polynomial in time. It's a fake one, but it was working. It was like publishing in electronic letters. And I know many people that days, 15 years ago, thinking that it was true. Okay, so, well, 15 years ago, a joke, a 1st April, was working. Here we are not the 1st April, we are not joking. Maybe it's working better. Okay, so maybe also, maybe some people are able to factorize keeping the secret. You don't know the Coca-Cola recipe normally, the Google search algorithm, and so on. We share everything, but in fact, we don't know exactly the theory, we don't know the limit, and so on. So maybe the solution is not published, maybe there is no solution, and maybe it's not enough to change or extend the keys, maybe it's a big change to do, to migrate to another system. Maybe the name will be really secure algorithm. Oh no, it's not that good, RSA. Okay, so part 5, but I have 5 minutes, so it's okay. Science fiction. So Titanic was thinking that dates in number theory, we don't know. Think about the reaction, chain reaction. So if you solve something, integer factorization, maybe you would solve other things. So maybe the replacement solution is not enough. And maybe a good resolution method, maybe there will be an impact in other algorithms. Stream ciphers, hash function, I don't know. So what to do? Think about the Titanic disorganization, but think if you factorize, what will have, people will revoke, discard the certificate. There will be massive recall, class action, well, everything, legal action. And what about the remedy? We don't know. We don't know the cost. We don't know if there are studies. We don't know. Okay, so there were 3 boards. The name is DL, EF, and CC. There were an algorithm attack, 2 algorithms, structural weakness, and not enough replacement solution. So maybe we are in that situation, maybe in the future. We have a lot of security precaution at the moment, prime generation, prime testing, prime generation, and so on. But if factorization is fast, all the security precautions we are using are for the past, is done. So now people think about seeing your own Titanic. People are doing that also sometimes. They are doing that at home. You can use some grid or clues, FPGA, and so on. Maybe there are algorithmic or other improvements. So maybe it's not so crazy to think that somebody in his basement are maybe doing that. We don't know. So we need to take appropriate measures of security. Here a lot. I don't have time to say that, but if we are enough clever to solve a hard problem, maybe we are also able to come back to security. I think that I will skip this one. It's how to prove that you have a factorization algorithm, but without giving the algorithm. Now, the next step. Here we are proposing a new workshop. The name is, at the moment, Catacrypt. And this dedicated workshop, related to catastrophic events, for when cryptography is used and their possible recoveries. for the keys, for the hardware, for the protocol, for the intellectual property, thing about DRM and pay TV, thing about PKI, the recent story of DigiNotar, and also thing about the paper here in 1 hour about sovereign keys. We need that. There are sometimes some indication. The first workshop will take place next year, maybe not the day of the Titanic having 1 century. So look for the future call of paper. A first pointer, there will be another one. Is at the moment there is nothing there. It's demultiply.com. There are many big companies having put interest about that. I cannot give you at the moment the names. If you are interested, say to us. We will see how to handle that. And thank you for your attention.